So now that we've explored doing some of the stop words and stemming using SQL natively, we're going to do the much easier way of doing this by building on the Postgres capabilities. And their stemming and stop words and their ability to store this data very densely far surpasses our ability, because they can build indexes specifically for this kind of stuff, and they can tweak it and have extensive stop word lists. So really what I just showed you with the docs.gen was just to give you a sense of the kind of basic data structures that Postgres is going to make on our behalf. Now, before we get into how to do it, turns out how to do it's not hard at all. There are two really important functions. So in the previous examples, we were using string to array to split strings into words. There is a language aware function, two functions called ts_vector and ts_query, that basically take strings and turn them into an internal structure. And so this select to ts_vector, you'll notice that we have to tell it what language it is, because then it's picking a dictionary for stemming and stop words and other kinds of tuning. And what that does is it goes and does the stemming and stop words and tells you, along with the position, the non-thrown away stuff. So you'll notice that and is thrown away. And so that's and you can see the stemming if we say to ts query in teaching. You can see that teaching is stemmed down to teach, just like what we did in the previous example. And so then in the where clause, the ts query is a thing you're looking for, and a ts vector is a thing that you're indexing. Okay? And this function to ts vector and to ts query converts using a language to either a ts vector or a ts query object. You'll notice ts query doesn't have a position in it. These are the positions. Also is twice in positions 2 and 6. Python is in 4th position. SQL is in 7th position. Teaches. That's what those numbers are telling you. We use this double @ sign operator, which really is you think of it. You can put various things on one side, but I think of it as like left side ts query, right side ts vector. It returns a true or a false. So let's go ahead and run these commands. Again, I'm using the www.pgfree.com lectures/05 fulltext SQL. For the samples, we can run some to ts vector commands. I'll just copy all three of these to ts vector commands. So these selects that have no tables, they're just kind of running the functions, and you'll see like people has been stemmed, learn, that one. The stop words are all happening, and so there you go. So that's the to ts vector. Ts query, you can see some stemming going on. Let's grab these next four. We're going to do a to ts query of teaching, teaches, and English. So teaching as a query is teach, teaches as a query is teach. So that's two examples of stemming. And if we do a to ts query of the word and, it complains, hey, don't put only stop words. So I put a stop word. And is a common stop word. But you'll also know that, and you do a to ts query on something like SQL, which it doesn't have a stem for, and it's not a stop word. It just converts it to lowercase and gives it to us. Now, again, we worked really hard to build all this in SQL with like 5-6 line long select statements, and the to ts query does all this for us. So that's quite nice. So you can also put logical operators, the to ts query with the vertical bars as or, and so you can think of this ts query being sent to the database. I wish it would be clever enough to realize that teacher, teacher, teach, or teach. You know, you see that it stemmed, it lowercased, it threw away stop words, and it should really just say teach, but teach or teach or teach. These TS queries, you can think of them as being sent to the database. Like, hey, database, you have all these documents. We're going to hand you this query. It's a parsed query. It's like a compiled query. We're firing it to the database, and the database is going to scan the rows. Or, if all goes well, it'll use the index instead. Now, there's a couple of different ways to do this. There is plain text to TS query, like In this case, plain to TS query of SQL. Now, let me grab both of them. This one I don't like so much because it implies all the words have, it implies and of course it's doing stemming and it's doing, but if you do this plain to TS query, that implies and between all of the operators. There is a phrase, and that basically says we want, phrase to TS query says I would want to see SQL followed by Python, and again stemmed in lowercase. If you are Postgres 11 or later, which I happen to be in this particular one, you can do web search to TS query. Now, web search to TS query uses a syntax that I think was pioneered by Google that's got a couple of special things in there. It also tolerates, it does something if you have like a syntax error. It doesn't freak out, and you're kind of expected that this can be typed by the user and not blow the system up. Some of these things like plain to TS query or to TS query, you can type syntax errors in the query, so you have to be careful. But the phrase to and the web search to don't need that, okay? And so we can ask, we can ask whether or not a particular query is inside of a particular text vector. And this is kind of where you're stemming and stop wording. So you have to stem and stop word the query, and then you have to stem and stop word the thing that you're querying. So we'll stop here, but then up next we're going to show how you actually do the index using these functions.